Good afternoon, everyone. Thank you for joining us at this virtual conference. I, for one, am so impressed that we've developed communications technology adequate for handling teleworking and staying connected with this community during these safer at home times. This presentation is about the regulation of small cells, especially in light of the FCC small cell order, and particularly on the subjects of aesthetic design guidelines. And in this presentation, I'll introduce a framework abbreviated by SCARF for categorizing design guidelines according to urban design principles. In part 2 of this presentation, Ken will present example case studies of design guidelines that HR Green has worked on, which demonstrate how small cell federal and state requirements affect individual communities and how the aesthetic design principles introduced in this part of the presentation can vary depending on local conditions and circumstances. As many of you practitioners in the field know, the FCC small cell order has been developing over the last few years. It started with a petition filed by Mobility in 2016, went through the formation of the BDAC, a number of proposed rulemakings, report on order, declaratory rulings, and finally a release of the order, which then was challenged in court in a number of court cases, which were then decided in just a couple of months ago in August of 2020. The court's decision is generally seen as a big win for wireless carriers. The issues that were resolved with these court cases involved the interpretation that the FCC made of the Telecommunications Act of 1996, especially the discrimination provisions that are defined as prohibit or have the effect of prohibiting service. And the definition of materially inhibit can apply to moratoria, fees, shot clocks, and vague aesthetic guidelines. When it comes to moratoria, expressed and de facto moratoria, which put deployment on hold, are not seen by the FCC as necessary to protect public safety and welfare. In relation to fees, the ones that are reasonable are under a safe harbor, where application fees are limited to $500 for up to 5 small cells, $100 for each beyond 5, and recurring annual fees of $270 a year. Localities can justify changing fees above the safe harbor with a demonstration showing higher actual cost. As far as the shot clock rules, they maintain them as 60 days for small cell co-location and 90 days for a new small cell structure, which kind of align with the 2014 Spectrum Act, Section 6409. However, they did not adopt a deemed granted remedy if the shot clock runs out and a municipality does not act within that amount of time. The last one deals with vague aesthetic guidelines, which is the subject of the rest of this first part of the presentation. And in another related part of the proceeding, which dealt with whether local authority to act to regulate their rights of way is in a regulatory or proprietary capacity, has to do with a portion of 1996 Act, which excludes public power utilities, cooperatives, and municipally owned utilities from being included in regulation governing their proprietary assets. Ultimately, the court determined that those types of utilities are also restricted by the same regulations that apply to all of the other types of utilities. So more specifically, the subject of this talk has to do with vague aesthetic requirements and how communities can better define exactly what they mean and what they intend by prescribing aesthetic requirements in accordance to requirements by the FCC. As many of us know, since the small cells have started being put on our community streets, they have been widely inconsistent, and the technology has been slow to develop in a form coherent factor. So the question becomes, how can communities create a comprehensive set of guidelines to something that is inherently subjective? Nevertheless, the small cell order does state that communities have to regulate aesthetic guidelines under a certain set of requirements. The first one is that they must be reasonable. The second is that they're no more burdensome than those applied to other types of infrastructure deployments, meaning that they need to all be treated equally to some extent, and they need to be published in advance. And there was a time limitation set out in the order that was very specific. It's 180 days from when that order was published, and the deadline was April 15, 2019. So traditionally, urban design guidelines typically use words like contextual compatibility, aesthetically pleasing, neighborhood character, cumulative impact, or a city's landscape, architecture, and built environment has a common identity and culture, which needs to be passed on through generations. So these terms, like many others describing art, are obviously pretty imprecise and difficult to apply to new and innovative structures. Art is subjective, but to some extent, professional standards of urban planning and design do provide a set of principles and practices in integrating aesthetically compatible and contextually appropriate functional infrastructure. These principles set a structure for how people may perceive, contemplate, feel, sense, and appreciate their experiences of public spaces. So a city's landscape, architecture, and the built environment is fundamentally concerned with continuing a sense of cultural identity of oneself and public identity as an affirmation to others. And architectural design reflects and codifies this practice and perception, and how participation in social life is, to some extent, an interpretation of conventions and traditions and experience. So when cities strive to create a balance between the need for wireless services and preserving this aesthetic quality and historic character or pedestrian-friendly design of streetscapes associated with integrating facilities into the surrounding environment, cities are concerned with ensuring that small cells are congruent with the existing urban design, that they're minimally intrusive and aesthetically acceptable and pleasing. So small cells do fit in to some extent to previously established categories of architectural design elements. It's fairly evident that the way small cell design is restricted has to do with their nature as vertical linear structures that can be organized in a number of spatial distributions. So in the way that aesthetic guidelines describe these principles, they include a specified order of preference for wireless infrastructure based on existing utility aesthetics, preference for co-location or standalone sites, spacing requirements between and within carrier network nodes and other utility poles into buildings and street furniture and other structures that may exist in the surrounding area. They also regulate size requirements for antennas and equipment enclosures, protrusions into the sidewalk, and generally are concerned with creating consistency and uniformity, as well as camouflaging and hiding the most incongruent aspects of the structure's design. So based on these existing architectural principles, we are able to create a categorization of elements as they apply to small cells within this framework, which we call the Small Cell Aesthetic Requirements Framework, shortened to SCAR, which consolidates and summarizes urban design, architectural elements, and small cell design requirements within these 4 sets of principles, characterizing aesthetics of small cell design within the principle of function, meaning that the site should fulfill its practical functional purpose, the principle of concealment, where sites should have the lowest visibility possible, the principle of balance, a site should maintain order and symmetry of itself and within its surroundings, and the principle of contextual compatibility, where a site should be appropriate to the objective perception of its environment. So all of these principles are to some extent interrelated, and each influences others to create a cohesive aesthetic. The principle of function can sometimes be at odds with concealment or contextual compatibility. It could be that the principle of balance and contextual compatibility are complementary to the principle of concealment because they promote the type of least intrusive visibility characterizing aesthetic appropriateness. And other considerations may also be considered as part of these 4 principles, but are seen as secondary to their fundamental aspects. So part of the methodology involved in creating this categorization structure involves having a sizable sample of aesthetic guidelines from many early adopters and creating a cross-comparative study in light of the fact that many of these cases have a wide variety of contextual environmental factors. Each city and community may be very different in its economic development, size, policy priorities, complexity, growth level, the amount of bureaucracy and hierarchy in the government, the way that the process splits and divides the administrative division of permitting responsibilities, or just the availability of human or fiscal resources. So I'll present each one of these principles in order. The first principle is very straightforward. A site, a small cell, should function as it was designed. If you notice on the slide, there are many types of sites, and the first image demonstrates at least 4 of the most common ones. If you have a utility pole attachment, if you have a utility pole with a street light, if you have a combination pole, and so on, there are a number of different ways where you can install a small cell on a new or existing pole. Since in many situations, a small cell is going on an existing pole, it's very important for a municipality to keep track of all of the application materials in a consistent and uniform manner. So this slide kind of demonstrates some of the requirements that it's important to uniformize as a small cell is going through the application process. The second principle is of concealment. So the site should have the lowest visibility possible. For example, you can see putting a pole in between buildings is much less intrusive than potentially putting it in front of a building, in front of a walkway, a door, a window. And similar requirements. Cable control is one of the more important and often forgotten about concealment requirements. Also, cohesive design requires very well orchestrated and thought about transitions between equipment and different aspects of the pole. The third principle is the principle of balance. So the eye is drawn to inconsistencies, disorder, and dissymmetry. So in creating a balanced and contextually cohesive small cell network, symmetry between sites and other objects around it, such as trees or other poles or other structures, should be maintained. And the last principle of contextual compatibility is that a site should be appropriate to the objective perception of its environment. So it's not necessarily as important how many elements the site has or how big it is. It is more important that it fits and is least visible within the context where it is located. So understandably, within a park, a small cell would have very different contextual considerations than within industrial plant area. So many communities can get very particular on the type of neighborhood and the type of site that they will accept, depending on what else is within that district or within that zoning area. So within that context, this slide demonstrates the types and ranges of possibilities that different cities have implemented for the sizing of small cells. So it really widely varies between communities what they prefer. Some communities will accept a base cabinet and some would prefer an external ground cabinet. It also very much depends on what kind of infrastructure they already have existing in the area. Similarly, a lot of communities, to avoid the scenario, as you can see in picture 1, of every single carrier having its own pole consistently deployed throughout an area, there are spacing requirements. In Colorado, a common one is 600 feet between sites of the same carrier. There are also many spacing requirements with street furniture, bike stops, curbs, street lights, driveways, entryways, and so on. As you can see in this roughly drawn demonstration, many cities have pretty uniform requirements for certain obstacles such as trees or historic landmarks, but they can vary very widely for things like streetlights or driveways or intersections. In general, we're starting to see more of a convergence towards slimline and multi-carrier locations as the technology improves, as community preferences become more well defined, and as some of the technological challenges with co-locating multiple sites become increasingly resolved. This slide kind of demonstrates how cities can define the spaces on their streetlight poles for different types of applications, and how multi-tenant sites can be located differently depending on cities' preferences. Many cities are also very highly varied with their preference for locating on traffic poles. Many cities do not prefer that small cells are located on what is considered to be an essential utility and an essential infrastructure for traffic management. However, some communities do have guidelines where, as long as a carrier can maintain separation between these functions, they can sort of revitalize an intersection with their infrastructure as long as they conform to a previously accepted and approved design. So these questions and issues and developments are really a reflection of how we're coming up on an ecosystem of devices with many new layers of hierarchy that require many new coordination mechanisms and interface management for communications technology. And increasingly, all of these will need to fit into denser environments. So it's not only going to be wireless service, it's also going to be a lot of Wi-Fi, CBRS, public safety, and other types of equipment. Then as the network infrastructure develops, a number of secondary applications will start running on top of this wireless infrastructure, and plenty of smart city and Internet of Things applications. So to give an idea of the variety of devices that are coming, are smart grid control lighting devices and other kind of utility control systems, meter reading, shot detectors, security cameras, traffic and congestion sensors. We can monitor the environment a lot better, temperature sensors, pollution, fire, snow, earthquake, floods. And of course, we're definitely eventually going to see a lot of connected cars and intelligent transportation systems, self-driving cars, smart parking, maybe even delivery drones, docking stations. So as we're wrapping up this segment on talking about how to classify aesthetic design, where art is something that is just intrinsically subjective, the SCAR framework outlined here helps us start to wrap our minds around how new wireless small cell technologies can fit within our communities, character, style, and architectural expression. Now I introduce Ken Price, who will cover the second part of this presentation and discuss some case studies to demonstrate how these principles can be applied.